All right, the doors are closed, so I can go ahead and get started now. First of all, thank you for joining me this afternoon. If you are here, I'm assuming that you want to learn more about identity and access management, or you want to fine-tune your policy creating skills, or you're just a die-hard fan of looking at JSON documents. Thank you. My name is Jeff Ware, and for the next 44-ish minutes or so, we're going to take an in-depth look at the access control policy language. Now, as a member of the IAM team, I can think of no better way to spend 45 minutes of my life but looking at JSON policies. However, you all might not share my same enthusiasm, so I want to give you fair warning. I am going to go through, look at a lot of policies, explain to you why they work, why they don't work. If you are visually impaired, such as I am, you might want to move towards the front. I do not bite, but you've been warned. So I just want to go ahead and start off with some of the goals. So really simple. By the time we leave today, I hope we all feel like we have a more in-depth understanding of how to secure the resources in your AWS account. And the way we're going to achieve that is by getting a deeper understanding of the policy language. I frequently participate in the IAM forum, and probably the most common question I see is, hey, I'm trying to accomplish this. I need a policy that does foo. How do I get that to work? And so through the course of the next 40 minutes or so, I'm going to share some of the tips and tricks that I've learned over the last couple years. And I may have mentioned this before, but we're going to look at a lot of policies. Probably not the most exciting topic that you'll sit through this week, but I'm going to try to keep it lively. I've picked out some of the policies that I think people have struggled with the most, and I'm going to do demonstrations of those. And normally I would ask you to ask me questions to keep me awake. Given the time frame, we're not going to be able to do that, but I promise I'll stick around afterwards. If you have a question, write it down, and I'll try to address those in the hallway. So I mentioned I was going to do some demos, so why don't we just start off there. So let's imagine you're new to AWS, and I'm sure some of you are, and you've heard about this cloud storage thing, and you want to take advantage of that to provide kind of a home directory for your users. So I want to have end users, and I want to create a home directory for each of them, and I'm going to go ahead and create a user policy that limits access to a folder. If you're using S3 terminology, a prefix within a bucket. So let's say I have a user, and her name is Sally. Maybe I have the bucket, a home prefix, and then her folder, and I want her to have access to all the resources in there. So let me show you what this looks like from the perspective of the administrator. I'm going to flip between Chrome and Firefox because I'll be logged in as the admin and logged in as the user. So here, if I look in S3, I have a set of buckets, and in there I have a test bucket, of course. And I've created a folder structure. So I have home, and I have Sally, and she has a total of 1 document in there. And so I want her to only be able to read and write to that folder. How might I go about that? Well, if you're new, you might do a little bit of searching. You might read the documentation, maybe. Find your way over to the IAM console, and you go in, create a user, like any good cook. I've already done that. I have the user in there. She's not a member of any groups. She doesn't have any policies attached to her, so I'll go ahead and try to attach a user policy. Now, if you've ever used this before, you're going to be familiar with our policy templates. These are sort of blueprints that you can use, getting started blueprints for a policy. And there's 2 of them for Amazon S3. So one of them that provides full access. So I don't want that. Don't want to give her complete access. And another one that provides read access. So obviously this would be something I could look at, but it's not necessarily going to achieve my scenario. Luckily, we have the policy generator. So I'm going to go ahead and select that. And I'm going to create a policy that allows. And I'm going to search down here for Amazon S3. And there's a whole lot of actions that I could choose from. So for simplicity, I'm just going to select all. And I got to put in the Amazon resource name. What is that? So, okay, I remember over here in the S3 console, if I go to my bucket, I look at the properties, I'm like, well, there's the name of the bucket. Maybe that's it. I'll go in, drop it in. Let me try to add it. If you can't see it, it says the resource field is not valid. You must enter a valid ARN. So I do a little bit more web searching. Maybe I read the documentation, And I realized that what you enter there is, in fact, an Amazon resource name that looks more like this. So I find out the structure of that, I copy it in, and now I can start adding conditions. So remember, I had a certain prefix that had to match a string like, and there's a prefix, and it looked something like this. And now I can go in and add that condition. Now allows me to add the statement, and it generates a policy. So now I have something that allows all actions for this prefix on this bucket. So I'm good to go, right? It's going to work. Click Apply. I'm going to switch over to Sally. So I'm now Sally in my account. I'm going to go to the S3 console. And I'm going to get, you don't have permissions to use the Amazon S3 console. If you need assistance, contact your system administrator. I am, in fact, the system administrator. So where do I go from here? So I think for a lot of folks, that's the first experience they get when they're trying to use the access control policy language. And I show you a fail condition only because I want you to learn from a common mistake that a lot of people make. And so what I endeavor to do through the remaining part of this presentation is walk you through how you would create such a policy, how you would avoid those types of mistakes. And it starts with the policy language. So identity and access management does two things. We authenticate you, right, validate your identity, and then we authorize you and provide you with permissions and entitlements. And the way to describe that is through our policy language. There's two things we're going to cover. First one is going to be the specification. We're going to spend a lot of time looking at how do you define a policy, what are the parts of it, sort of the semantics of it. And then towards the end, I'm going to go through how we do the evaluation and how the enforcement works. And it's the combination of the two, and then quite honestly, a lot of experience. It's going to help you write great policies. So you probably already know this, but policies are more or less JSON documents. And they all include a statement, which are a set of permissions. Now, those permissions have actions, or what a principal, a person, or a service can do, and the resources that you need to access. And I showed you a couple of templates from the management console. One of them was the read-only template, and this is an example of the APIs or actions that you would grant if you wanted somebody to have read access to every bucket, every object in your S3 account. Now, let's break this down a little bit further. Every policy has has certain elements, and I like to refer to these as the PARC model, specifically the principle, the action, the resource, and the conditions. There's also an effect. That effect is either an allow or deny, but ePARC doesn't really roll off the tongue, so I'll say PARC, and I'll say, plus you can allow or deny a user. And these two examples on the side are just snippets that would show this is how I would allow a user access to a bucket, and the other one is how I would deny a user to delete a bucket. We're going to get into more detailed examples in a minute. So I want to walk through each of these because the way that you define them is a little bit different per service. So the principal, if not obvious, is the entity that is going to be granted or denied access to a resource. And I'm going to up front talk about policies that would be attached to, say, an IAM user or an IAM group. There are also policies that can be attached to other objects. I will show those, don't worry. But if you are dealing with a resource-based policy, maybe attached to a bucket or a topic, you're going to have a principal element. So a lot of people create websites and they need anonymous access to certain resources. And if you were going to grant anonymous access to a resource, you would use the star.star principle. Likewise, you might have multiple accounts. You might have business partners where you need to share resources across your account. In that case, you might be using the root principle. This can be specified two different ways. You either put in the 12-digit account number, or you can put in the full ARN for the root account. Now, hopefully a bunch of you attended our AWS Security Best Practices session. You're all creating IAM users, and you're not using your root account. And so in that case, the ARN for a user is going to look more like this. If you're using Cognito or any of the identity federation services that we provide, you might see principles that are coming from Amazon, Facebook, Google, or others. Hopefully, some of you attended our delegation and federation session yesterday that Sean did. In that case, you're going to use lots of roles. So the role line is going to become important when you're defining principals. And then there will be times where you need to grant access to services. So there are service principals. For example, if you're using roles, and I hope you all are, when you launch an EC2 instance, you're actually delegating access to the EC2 principal. And so that's what it would look like. Oh, and if it's not obvious, I'm using fake account numbers here. So if anyone were to go and copy and paste, you'd want to replace with your account number. Actions. Now, actions describe the type of access that should be allowed or denied. Now, you'll see a lot of examples with the action. There's also the negative, the not action. And I'll go in detail into what that is. And so these are almost, sometimes I'll call these APIs because for the most part, there's a one-to-one between an action and an API. But just to give you an example of some of them, this is for the EC2 start instance. This is if you wanted to grant a user to be able to change a password. Get object, we've looked at it a couple times. I'll pause here because actions don't need to be a single item. You can specify an array of actions. And if you do, you just group them in square brackets. Likewise, we have wildcards. So let's say I wanted to grant my users the ability to create, delete, list, or update their access keys. I could create an array with that entire list, but it might make my policy big and unwieldy. So in that case, you can go and you can use an asterisk, which is a replacement for multiple characters, or you can use a question mark, which would replace a single character. Okay, I want to go through not action because a lot of people get confused by what we mean by not action. The easiest way I can explain it is not action allows you to specify an exception to a list of actions. And the nice thing about this is it can result in tighter, easier to understand policies. So let's say that you wanted to allow everything but the IAM APIs because you want to create a power user and that power user shouldn't be able to have administrative access. One of the things you could do is you could create a policy that says allow not action IAM star for resource star. And this will give the user access to every API and every API in the future that is not in the IAM namespace. Or alternatively, you could grant access to every API and explicitly deny the IAM actions. Any experts in here know what the difference is?
The first one is going to allow it first, and you won't get to the deny.
So the attempt is that you would get to the allow first and then never get to the deny. It's not true. What is actually the thing that I'd point out here is that a not action is not equivalent to a deny. A lot of people mess that up. So if, on the left-hand side here, if I were to add this user to a group that had access to IAM, maybe I did it accidentally because I was fat-fingering something with the CLI, that user would in fact have access to the IAM APIs. However, a deny always trumps an allow. So even if you were to take this user and put them in a group that explicitly granted them access to IAM, the deny would trump that. So on the right-hand side, it's kind of like a safeguard. You could never have it. Now, if you really want to get even more strict, you could use a not action, so I'm not granting you access to IAM, and I'm also denying that you could ever have it. So if you're really security conscious, that may be the policy that you want to use. So resources are the objects that you want your users to be able to request. And just like action and not action, there's a resource and there's a not resource. So we looked at a couple of these already, and just want to show you some examples. There's the S3 bucket, what we saw, SQSQ, Dynamo tables, which are actually pretty long ARNs. And then last but not least is the EC2 one. And this is going to be an important one for most of you because knowing how to really lock down access to your EC2 instances is critical to the security posture for your account. And I got a whole section on this presentation on EC2. Now, thus far, we've looked at a lot of policies that live with a user, a group, or a role. For certain services, you can also have policies live with the service. So in the case of S3, SNS, and SQS, you can have a bucket policy, a topic policy, or a queue policy. And this is going to come in handy when you want to do kind of the cross-account. So a couple things I'll point out here. First of all, we talked about the principal. When you create a user or a group policy, hopefully it's obvious that you don't have to put a principal in there because we know it's for that intended audience. But if you were to put this policy and this is an XQS policy, we would need to know who you're granting access to. So in this case, we have an account 1s, 2s, and 3s that is able to access a queue in account 4, 5, and 6. So that's a resource-based policy. Now, the last part of the Park model are conditions. And conditions are optional. They allow you to add in additional criteria, and that criteria must eventually evaluate to true in order for the entire policy to evaluate to true. Now, conditions have elements and can contain multiple conditions. So case here, I have a key, and that key must evaluate to this value, and I have key 2, which also must evaluate to another value. Now, condition keys can also contain multiple values. Likewise, a single condition can include multiple values for a key. The condition is evaluated using a logical OR. If you have multiple conditions, or you have multiple keys within a single condition, then the conditions are evaluated using a logical AND. And this may be a little bit confusing. I actually think it's a little bit easier to look at if you look at a real example. So let's say that I wanted to create a policy that will evaluate to true if the time is after noon today, but before 3 p.m. today, and it comes from either of these two address ranges. The address ranges would be a logical OR, and then the 3 other conditions would have to all be true in order for the policy to be true. Make sense? Hopefully. Okay, the last part of the specification are really policy variables. Policy variables are, I would say, relatively new. It's something that we introduced about 18 months ago or so. And these are going to really help you tighten up your policies. Now, if you remember when I went through that fail scenario of trying to create the S3 home directory, I had to go in there and explicitly put in Sally's name as part of the prefix. Now, you can imagine if I had hundreds or thousands of users, it could be really annoying to have to go and explicitly put that in. How about instead if I could just replace that with a username variable and then I'd have a single group policy that I could manage? It'd be a lot better, right? It's exactly what you get with policy variables. So there's a number of use cases these also simplify. We looked at the home folder one, but other common scenarios are, hey, I've created IM users and I want them to be able to rotate their creds. Or I have certain IM users and I want them to use virtual MFA and I don't have access to their cell phone, so I want them to be able to set up and deactivate MFA. Last but not least, being able to use tags as security attributes on EC2 instances. Variables are going to help you solve all of these problems. Now, variables are not something you define. They're something that we provide to you, so they're predefined. And they are based off of the existing keys. So for example, in the previous condition, I showed source IP and current time. They can also be principal-specific keys, such as the username or the user's unique ID. If you're using some type of identity federation or using Cognito, you're going to have identity provider-specific keys, such as Facebook or Amazon. And then if you're using enterprise federation with SAML, you're going to have keys like the issuer or the audience. So all of these become tools that you can use inside of your policies. So this is what a policy looks like using variables. And the first thing I'm going to point out is the version. It's like really important that you put the version in your policy. If you do not put the version in there, it treats the variable as a literal. And I cannot tell you how many times I've seen people, they forget to put the policy in there. Now, if you're using the tools today, the tools actually put the version in there for you. But if you have a policy that you've been using for a couple years, I guarantee you it doesn't have a version in there. And if you try to go in and replace it with a variable, it's not going to work. And then you're going to post to the forum, you're going to scream at your computer, you're going to do whatever you do to vent, and then you're going to realize that you didn't have the version. Now, you can use variables in conditions. So here's an example of the user ID in the condition, and you can also use it as a variable in a resource arm. So let's get back to that original scenario of giving a user a home directory from the Amazon console. So this is where experience comes into play. First thing I'll point out is we have the version. The next thing is understanding what APIs the management console uses under the covers. Now, the good news is this is all documented, and since you all read the documentation, you should know this, correct? So these are the things that you need to put in there, which may not be really intuitive. So when you get to the management console, the first thing it does is it tries to get the bucket location, and it tries to get a list of all your buckets. If you haven't granted that for all of your buckets, the user's not going to be able to see anything. So that's really the reason why we got a access denied in the first example that we looked at. The second part of the policy here is for list bucket. Now, list bucket works on a resource of the bucket ARN. And what we want to be able to do is go into the root of that bucket and look at anything that is in the root folder or anything in the home folder where there's a delimiter of a /. And this is using a string equals. So this will only evaluate to true if those are the paths. Now, once you're in the folder, you need to be able to list all the objects. And so once again, that's list bucket on the bucket ARN, but in this case, it's a string like, because the various objects might follow a pattern, but they're not going to be explicit. And so this is the home folder, and I'm going to use a variable here instead of using an explicit, Sally, Bob, whatever you put, and then an asterisk for everything after. And so this will allow them to see everything in their folder and any of the subfolders or sub-objects that they have. Last but not least, we need to allow the user to be able to modify those. Now, this is where understanding how the S3 APIs work come into play. So for list bucket, the resource has to be the ARN. For most of the other S3 APIs, it's actually the full path, including the bucket ARN. And so here, I'm allowing you to call any of the S3 APIs as long as it's in the root of my folder or anything in the subfolders. So let's get back to that original scenario. So the goal is still sort of the same. I want to create a single group policy that limits access to a prefix in an Amazon S3 bucket. And this time I'm going to be using a user named Bob, and he's going to have a path in that folder. So I'm going to show you the group policy that uses variables. We're going to enable the user to list the buckets in the Amazon S3 console, and then I'm going to lock it down so that there's nothing else they can do inside of my account. So the first thing I need to do is actually log out as Sally. Sign back in as Bob. And if you guys haven't seen this before, I'm logging in as an IAM user. And because we all follow security best practices, I'm using MFA. And now I'm going to log in, and I'm going to go to the S3 console. So unlike the experience for Sally, Bob is not going to get an access denied. And just as the policy granted, he can see all of my buckets, although he cannot log into any of them. If he tries to go in, he's just going to get an access denied. So this is one of the compromises you have to make. They're going to be able to see all the buckets. They're not going to be able to touch them. I can go into the test bucket that I granted him. If I try to go into any other folder, he's going to get an access denied. I can drill down into the home folder. I can drill down into my folder. I can click on objects that are there. Bob stores pictures of my daughter, which is a little weird. Good for Bob. So you can see that we're able to lock down. Now, what did I do in order to grant this to Bob? It's literally the policy that we looked at before, but just to prove to you that it's all live, if I go in and I look at Bob, Bob is a member of a bunch of groups that I've already set up. And so there's a reInvent S3 home folder. And if I go and I look at the policy, I can boost that up a little bit. Sure enough, it's the exact same policy we looked at in the slides, set of permissions. The only real difference is, I'm using the actual bucket that I'm using in production. Okay, so that wasn't a fail. That was actually a success. Let's look at some of the other common scenarios that you want to do. So if you want your users to be able to manage and rotate their own credentials, if you want them to be able to manage their own virtual MFA, you're going to have to grant the user access to the IAM console. This can be a little bit intimidating because once you start granting IAM APIs, you're like, did I get it right? Did I just give this guy the ability to create users and own the account? So just like the S3 console, you have to kind of be conscious of what the underlying APIs are being called. And so here's a two-part policy. The first part of the policy grants IAM list users, and it does this for all users. And so just like in the S3 console where you could see all the buckets, this is going to allow you to see all the users. Now, you're not really going to be able to see anything about those users other than their names. What I'm going to grant him, in this case Bob, the ability to do is call IAM get user, get login profile, which more or less tells you if there's a username, a password associated with it, be able to list the groups, and list the access keys. And I'm only going to do this if the user matches this variable. And so this is a group policy. For Bob, it'll be Bob. For Sally, it'll be Sally. And so those are the only attributes they're going to be able to see for that user. So that'll get them into the management console. But then how do I go about allowing them to manage their own secrets, per se? So in here, I have another policy. And this one grants them access to all of the access key APIs, create, list, delete, and also all the signing certificates if you're using those. And once again, I'm going to lock it down so it matches only that user's ID. Now, last but not least is virtual MFA. And I want to show you this one because you really should be using MFA for your accounts. But for a system administrator, it can be difficult to get a hold of your users' cell phone numbers to set it, their cell phones to set it up. And so in this case, you can enable your users to be able to turn on MFA on their own. So there's 3 parts of it. The first part is to create a virtual MFA device or delete it. And for this one, the ARN is actually an MFA. These look similar, so I'll try to point out the differences. This is actually an MFA ARN that matches the user's name. Now I want to be able to allow the user to deactivate, enable, list, or resync. ARN is a little bit different. This is actually on the user's username ARN. And then last but not least is just a little bit of the way the console works. In order for you to list the MFA device, even for yourself, you have to be able to list all the devices in the account. And so there's one action, IAM list virtual MFA devices, and for that you have to be able to see all the MFA devices in the account. So what if we want to put this all together and create a set of policies that allow users to self-manage their identities? So 2 goals. I want them to be able, I want them to be able to log into the console. I guess there's a 3rd goal. But I want them really to be able to manage their credentials and manage their own virtual MFA. We're going to have 3 policies, one that allow them to get into the console, one allow them to rotate their credentials, and one to allow them to manage virtual MFA. So let me go in here again, and I'll switch over to Bob. And let me show you this. This is what the IAM console looks like as the system administrator. So if I hit the dashboard, I can see all the information. If I go into the groups, I can see all the groups, users, roles. One of the things I'll point out in users here is there's a number of users. They have passwords. I can see when their password was last used. I can see they have access keys. Now let's do a compare and contrast on what Bob sees. So Bob fires up the IAM console. He goes in and he starts getting access denied. Now this is good. You want this because this is information he does not need to do his job. If he tries to look at the groups, if he tries to look at the roles, he's going to keep getting access denied, access denied. If I go to the users, just like being able to list all my buckets, he's going to be able to list all the users. But the difference is he can only see details for himself. So as far as Bob's concerned, no one's part of any groups, no one has a password, no one's ever used their password, and no one has any access keys. So there's a very limited amount of information that we're exposing to Bob. Now, he can drill into his own account, and he can see some information about himself, right? Some things he's not allowed to look at the group policies because we don't want him inspecting it and figuring out what permissions he's been granted. But he can go in here and manage his own access keys. So I can go in, I can create an access key, right? And now because all of you are periodically rotating your access keys, right? That's best security practice. Yeah, see, there's just some nodding heads. Probably 2 or 3 of you who do this. And so Bob is going to go through, and he needs to rotate his keys. He can create a second one. Then he can go in, and he can deactivate his key because he wants to test it, make sure before he destroys that key that his application is still working. He's tested it. He's like, yep, I don't need that key anymore. I can go in, and I can delete it. Of course, he may determine he doesn't need any keys at all, and so he deletes those. And so this is how you can enable your users, your developers, to go in and do the things by themselves and not have to do that as the system administrator. Now, of course, Bob is using MFA, and so he can go in there, and he could keep his MFA. He can go in and resync it and enter in codes. He can even go in there and deactivate it. I hate showing that to you, but with the policy, he has the ability to do that. And so if I look at Bob, once again, I've switched over to the admin console, just so you could see there's three groups he's a member of: the IAM console policy, the self-managed policy for secrets, and then the self-managed policy for MFA. And just to prove that these are indeed the same policies that we looked at in the slides, I'll bump that up a little bit. You can see no change. It's literally, if you want to use this, you get the slides afterwards, you want to use those those policies, you can. By the way, it's all in the documentation now. I mean, I make a joke about that, but I know how many of us actually read it, but these are all available in case you want to use them on your own. Okay, I want to get into an important topic, and we got about 15 minutes left, so that's about enough time to get into it. And that's around EC2 resource level permissions. So if you've been with us for a while, you probably knew that previously all the policies applied to all Amazon EC2 resources. And about last summer or so, we added the ability for permissions to be set on a per resource. And so this is important because now you can go and say, hey, this user, you can only mess with instances, hey, in a certain region, or you can only mess with this exact EC2 instance. Just to kind of show you what it was before, if you needed a developer who you want to grant them the ability to terminate instances, you had to grant them the ability to terminate instances in your entire account. There's probably still some of you who are doing this. So yes, there is a better way. If you really wanted to, you could go in and you could specify a resource that is down specific to an actual instance ID. Probably not always going to have those instance IDs. They're hard to remember. More commonly, you might want to say, hey, you know what? I'll let you mess around, but only in this specific region. You may be saying, can we do better? Of course. Tags come into play where now you can go in and you can use tags, not just as a way of filtering and putting some metadata on it, but you can also use it as an attribute for enforcement. And so in this case here, I have a resource tag named department and dev. And so now if I applied this to our friend Bob, he would have the ability to terminate instances as long as they were in US East and as long as there is a tag on it that says a department of dev. And I'll show you how you even get a little bit more specific in these types of policies. Excuse me, I'm sick, so I'm afraid I'm going to lose my voice. So there's a number of resource types that are supported, and then there are a number of resource types that are not supported. And this is where creating policies for EC2 is a little bit of science and it's a little bit of art. So here are the current resource types that are supported. I won't go through all of them. Once again, they're in the documentation. And then here's the subset of EC2 actions that support resource level permissions. And this is the full list as of today, unless they recently changed it without me knowing. So you have some of the common ones, like I want to be able to prevent people from rebooting, running, starting, stopping, or terminating instances. And for those, there's a set of resources that we looked in the previous slide that you can use with them. And then there's some obvious ones that aren't on this list, like describe, like all the describe and all the list APIs. So when you're using them, you have to make sure that the resource is still star. So resource level permissions in EC2 is sort of a work in progress. Now I mentioned this before, you're probably using tags as a way to categorize your EC2 resources. Likewise, you can use them for enforcement. So I have some convenience tags here around the name of it, the stack that it is, and then I have added a tag as an owner. An owner can be a really good tag in case you want to use that for saying, hey, anyone can use this, but unless you're the owner, you can't terminate that instance. And so tags are your friends in accomplishing that. So let's take a look at an EC2 resource level permissions. Let's pretend you want to limit a user from starting, stopping, or terminating an instance unless there's a tag on it that specifies he's the owner. I'll show you how you can add a tag. And then we're going to look at a policy that grants a user access to the EC2 console. So just like the previous two examples, you got to let them into the console some way. And then I'm going to use a policy variable to limit what that user can do once they're in the console. So once again, in Bob, I'm going to switch over to EC2. I don't currently have any running instances. But one of the things that you can see in here is I have an owner tag. Now, you're surprised when people don't know how to do this, but you can go in and this is where resolution failed me. I can go in here and I can add a tag, maybe it's my stack and maybe I want it to be production or something like that. And then within the UI here, you can go and make a configuration. So you see the owner column. Now you see it, now you don't, now you see it. That's how you turn that on. Tags are nice because I can go in here and I can filter on it. And so I can see this is the only instance that Bob has access to. So if I want to, I can start that instance. Everything works great. Let me turn off the filter. Show you there are instances that are also owned by me. So if I go in here, try to start that instance, it's going to get a failure. No matter how often you hit that, it's going to be the same result. And so let me switch over to the admin view of this. And once again, here's Bob. These are the list of groups he's a member of and the policies. And so there's one policy, and I will show you this in a slide because it's much easier to see that way, that grants him access to the management console. And then I have a second policy. Maybe I stuck them, no, sorry, I stuck them all in here at one. There's one policy here that grants access to the management console. And then the second part of the statement here is what actually limits what he can do from within. Now, I've been running this. It's probably, at this point, it's running. Oh, wait, I'm still admin. Go in here and look. OK, that instance is running. And so kind of just to complete the demo, I can prove to you that he can even, in fact, stop. And I'm so confident in this policy, I'll just show you that even over here, if you were to go and try to terminate, it's going to get an access denied. So. OK, so locking down access to EC2 instances, as I promised, there's really multiple parts in here. There's how do I allow the user to see everything they need in the management console? Now, there's an EC2 readers template, I believe, and I think you can use that, and that's more or less the top. So these are all just the describe or list. There's no destructive actions, per se. And for these, they don't support resource level permissions. So this would have to be a resource of star. And then down here, these are the actions that you really want to lock down. So reboot, start, stop, terminate. And I'm limiting him to the US East region when there's a tag of owner that matches his username. And so this is a group policy that you could use for any user that you would want to lock down access. And it's just highlighting some of the various parts of that policy. OK, ready for a quiz? There are no prizes for right answers. I told you you couldn't ask me questions, but I'm going to ask you questions. So, anyone know why this policy doesn't work? Yes, that's correct. So the answer is not all EC2 actions support resource level permissions. So when you, in fact, put in EC2 star, we have to try and evaluate every action, and eventually we're going to get to one that doesn't support this resource arm. And in that case, it's going to fail, and when things fail, we default to access denied. So the solution in this case is if you want to grant EC2 star, the only way to put it in is a resource of star. And I don't recommend creating that policy. So what if you wanted to run, terminate, stop, and start from the management console? And anyone know why this one won't work? Sorry? You need console access, but I've given describe star. There you go. Describe star does not support resource level permissions. So once again, this is going to fault and default to access denied because we can't interpret the policy. OK, so I've taken all the describe APIs and I put it into a separate action where the resource is star. So is that going to work? It's sort of a trick question. The answer is no, but the reason might not be obvious. If you want to run an instance, launch an instance, you're going to need access to additional actions and resources, such as access to instances, key pairs, security groups, volumes, AMIs. And so this would be the final policy that you would want in case you wanted a person to be able to describe certain things. Now, they're not going to be able to list. If you want to go further, you'd have to also add list actions and everything to get into the management console. But now you can see why people have a difficult time trying to build up these types of policies. So I promised you I would go a little bit through enforcement. And this is important so that you understand how these policies then get evaluated. So policies, remember, can come from multiple places. We look, it can be on IAM entities like users, groups, and roles. They can also come from a resource, so an S3 bucket, an SQS queue, an SNS topic. One of the things I didn't cover today, but if you were in the federation or delegation sessions yesterday, policies can also be passed in when you're requesting a session from STS. And when we get a policy, we go through a well-defined evaluation logic. So a request, very simple. It can be allowed or it can be denied. I mentioned this before, but if there's a deny in the policy, it always trumps an allow. If you're not allowed and there's no deny, well, you're still denied because we deny by default. It's just the way the system works. And then we're always evaluating all permissions. So we're looking at if you have a user policy and you're a member of a group and there's a bucket policy, we take the union of all of them to figure out what your permissions are. And so this is what happens when we walk through it. So by default, you're making a request. We assume it's going to be denied. We go and retrieve all the policies that are associated with the user and the resource, and only the policies that match the action and conditions are evaluated. And so we look at that and we say, is there an explicit deny? So it doesn't matter if the deny is at the bottom of the policy, top of the policy. We'll look through the whole thing. If there's a deny, then you're denied. If there's not a deny, is there an allow? If there's an allow, very simple. You've been granted access to that resource. If there's no deny and there's no allow, you're still denied access. You're back to where you started. Make sense? Everyone feel like they have a great understanding? Good, because now we got to my summary slide. So just a couple things that I want to reiterate before people take off. So as you probably already know, IAM provides access to your account. We took a look at the policy language, which is the way that we authorize that access. When we go through the evaluation, we look at all the applicable policies, and of course, denies always trump an allow. And then, if you're creating policies, use policy variables. They're your friend. They make things easier. And when you use a policy, use a policy variable, what do? You put the version number in there. Okay. EC2 is a little bit tricky. This is where the documentation is going to be your friend. Speaking of documentation, here's a couple of my favorite things to look at, including the doc that you would need to go to find out what actions support what resources for EC2. There's the AWS Security blog, which I recommend if you're not already following. There's a couple policies couple articles specifically on EC2 resource permissions, such as demystifying EC2 resource level permissions, and another one that shows you how to grant access to the management console. Of course, we have our website and our forum. If you have a question, pretty good chance I might reply to it. And of course, you can follow us on Twitter. Now, before all of you disappear, this is Security Session 303. I kindly ask you to go in and fill out the evaluations. It helps me improve year over year. It helps us improve the conference. And we really do take the feedback serious. So with that, thank you once again for sticking around, and hope you enjoy the rest of the time.